So it says this webinar is being recorded.
Yep, we're good.
Got it. All right. Great. We just wanted to show everyone how cramped we are here. So we packed everybody into this little room. And that's really how we are at School of Mines and in this building too. So I'm Steve Smith. I'm a professor and head of a new department, which is a merge between nanoscience and nanoengineering and biomedical engineering. We call nanoscience and biomedical engineering. So I'm going to give a little bit of an update of what's been going on this year and a little bit about who we are. And so let's get started. And I'm accompanied by a few of our faculty, students, and staff. So should we introduce each other? Right now, I'll just introduce everyone, or would you like to say your own name? Hongzhu?
My name is Kongzu Wang. I'm an assistant professor in our department, and I'm teaching Biomedical Engineering 101, Introduction of Biomedical Engineering. So if you join our department, I will be your first instructor. So you will see me a lot in your freshman year, and then probably you can, work in my lab. So right now we have Catherine and another girl, and Lisa working in my lab doing research. So my research is mainly focused on using nanomaterial to treat cancers. Yep.
I'm Vanessa. I'm the research engineer and instrumentation specialist in the department. I just started last June. So.
Okay, I'm Catherine Ballard. I just finished my sophomore year. I'm a biomedical engineering major. And then I'm also the treasurer for our student organization, Biomedical Engineering Society.
Hi, I'm Jonna Camaro. I am the Nanoscience and Biomedical Engineering Program Coordinator. I just got hired in August of last year. And so we just finished our first academic year together, and I'm really excited about seeing the program grow.
And I'm Brandon Scott. I'm currently a research assistant professor, and I'm an imaging scientist. So my research is really focused on doing live cell imaging to try and understand how immune cells eat and drink things in their surroundings.
So we're going to introduce everyone again in the next slide. So this is our staff, Dr. Morrow, who just introduced herself. So she's a coordinator. And some of the things that she does for our department are advise students. She also coordinates and arranges research opportunities. She's also in charge of internal and external engagement and assessment. Vanessa, who is an instrumentation specialist and research engineer. She works in our labs, runs the instrumentation and maintains it, trains students. And Leslie will be our program assistant. She's not started until June, but she will be the main point of contact for students in the program and alumni. Also, will support all our academic and research operations. These are all our faculty. So we have 8 full-time faculty. They're all listed there, including myself and Brandon and Dr. Wang and a few others who I'll introduce a little bit later. We also have academic advisors from other departments who advise graduate students, and there's a list of them here. So what's new, I wanted to talk about some of our faculty awards. With exciting years, 2 big Nsf Career Awards. So this is a big honor for our faculty. Dr. Wang and Dr. Wood both earned the Nsf Career Award. And Dr. Wang's career is about how nanomaterials can stop and kill cancer cells. And Dr. Wood's career is more about osteoarthritis and trying to understand the biomechanical origins of the disease. So we also have some new grant awards coming in. Dr. Scott is supported right now by Chan Zuckerberg Foundation as what we call an imaging scientist. So he catalyzed a lot of imaging research here, and he's been supported again for the next couple of years. There'll also be a couple of new NIH awards coming in. One NIH Cobra, which Dr. Scott and Dr. Anderson and I would be involved in. It's more about inflammation. And Dr. Wang is leading an area, R15. We haven't gotten the documents yet, but been recommended. So those are exciting things for our department. We also have a new award, which is a joint, which myself and Dr. Anderson have been involved in, and that is having to do with quantum materials. So we are joining what's called a Quantum Foundry, which is led by University of Arkansas and Montana State University in Bozeman. So we're excited to join that. We recently were interviewed on public radio about that. A little bit of our student awards. So we have a lot of awards. I just showed 3 of them here, but our exciting award is Laura Brunmeyer, our biomedical engineering PhD student, won an NSF graduate research fellowship. Kim Choik also won the CEO business plan competition for the state. That's exciting. He's a nanoscience and nanoengineering PhD student. And we have a couple of there's more than 2, but I just showed these 2, Jillian and Annalise, both won outstanding undergraduate students in biomedical engineering this year. We have a long list of PhDs from nanoscience and nanoengineering, 36 since 2019. We have 3 more this year. Several of those have wound up being faculty at different universities, 2 of them here at our institution. In biomedical engineering, we had 11 PhDs since 2011. We've had about 52 MS graduates since 2008. And BS, which was started in 2019, we now have 9 BS graduates. And this is a list of some of the companies where our students have found employment, mainly internships and post-graduation. So right now we're at about 80 for our BS program. Incoming freshmen, another 30. Current MS enrollment around 3, and PhD enrollment around 5 right now in biomedical engineering. So I just wanted to give a few snapshots of some of the research projects. I'm not going to go through these in great detail. A couple of the faculty are here, so they might be able to answer questions when I wrap this up. This one, Dr. Wood, is actually not here today. He's one of the Career Award winners. So this is just about join on a chip. So the idea is, can we reproduce the environments that cells would see in the body, for instance, but do it on a chip where we can control the reagents that react in environmental conditions. So this is a project which is ongoing. It kind of incorporates something Dr. Wood has trademarked, which he calls Cell Well, which is basically microenvironments for individual cells. All these little green dots are fluorescent signatures from single cells. This is just a snapshot of some of the work that Dr. Wang is involved in. And like I said, he's here. But it has to do with using nanomaterials to try to stop cancer migration and metastasis. So it uses both atomic force microscopy and optical microscopy to look at the structure of the skeleton of cells, what we call the cytoskeleton. These are images which were taken using a super resolution method we call D-STORM. A big effort here has been developing novel and volumetric imaging methods, and this is led by Dr. Anderson and with collaborators, Dr. Scott and myself. But basically what you're seeing in the animation is the surface of a cell as it endocytoses different materials. This is so it uses a method we call lattice light sheet microscopy, and there's a lot of optics over there, but the basic idea is shown in this little cartoon in the bottom of the, I'm going to go back of this, and you see what we do is we create a sheet of light and we just sort of scan cells through it, kind of like you go through a CAT scan machine, and then reconstruct a 3-dimensional or volumetric image from the individual 2D frames. So Dr. Scott has really taken this to another level by looking at immune cells and how they interact with the different foreign bodies. These are our B cells, which have been, I think, tagged with an antibody, and looking at how the membrane and how the cells actually interact with that foreign cargo. So studying two major areas, macropenocytosis and phagocytosis, which is basically cell eating and drinking. This is just a snapshot of some of the work in my lab, which is mostly optical imaging and spectroscopy. So we do a lot of multi-photon imaging, three-dimensional rendering using infrared lasers, which penetrate tissue so that we can look inside. This is actually images of a root, and the other is images of a vascular scaffold in an arterial wall. So these are some examples of some of the imaging that we've done in the lab. This is all part of a larger collaboration, which I call Imagine. It's a bioimaging collaborative. It's just a snapshot of some of the imaging using Lattice light sheet, using multi-photon, using AFM, a lot of different areas. So a little bit about the biomedical engineering program, which was started in 2019. I actually was asked to run this in 2019, but I had to defer because I went to the National Science Foundation that same year. So this was constructed by a group of faculty, some of the faculty, including Dr. Wood, who's in our department, and some of the graduate advisors you saw in the first slides. So this is our curriculum, and this is a flow chart for our curriculum. I'm not going to go through the details of that. I wanted to talk about some of the changes, though. We have some new electives which will be coming out, offered this year in fall and spring. And those are 4 new senior electives, never been offered before. And these are the names of the courses in imaging and signal analysis, tissue engineering, which we held in the fall, which we led by Dr. Anderson and Dr. Osdemer. And then in the spring, we'll have computational biomedical engineering and cell biomechanics, which will be taught by Dr. Wood and Dr. Scott. So I have a little here about the Engineering Society, Biomedical Engineering Student Society. And since I have, I think she's the treasurer.
Yeah.
Kathleen, she will talk a little bit about Biomedical Engineering Student Society, or BMES as we call it.
Okay, so at Mines, we have a student chapter, so Biomedical Engineering Society, it's a big national organization, and at Mines, we have a small student chapter. So we try to provide academic and professional development to students of all different types of majors, just to give them opportunities to see like what the field of biomedical engineering is in. We've had people with the BME major in like chemistry and biology. We've also had some mechanical engineers join. Right now, we have a big trip coming up in the fall to the national conference. So we're currently working on fundraising for that. But we do some smaller things throughout the school year. So we like to go on tours of different companies in Rapid City. We went to Hanger Clinic and Rise Custom Solutions this past year. And we also, a lot of the students involved are interested in healthcare careers. And so we also went and toured Avera Health in Rapid. And we also just like to do different socials, and you just get to know different people within and outside the major.
And they have their own foundation account, so you
Yeah.
can donate directly to BMES if you're interested in supporting some of those activities.
Yes, yeah.
That's the end of my presentation. I think that's what's new, at least from my point of view. I can stop sharing my screen and then maybe we can see, I guess we'll see ourselves. But if there's anybody online and they want to ask questions, we're happy to chat or elaborate on anything in my presentation.
Yeah, any questions or anything that you might have for the group here, please feel free to put them in the chat or in the Q&A, and I'll watch for them. I guess we do get questions every once in a while, and I think it was covered, but just in case, if alumni wanted to get involved, giving back their time and talent, what would be a great way for them to get involved with the, if options were available with the department?
Well, we have had people come and give seminars. So we had an alum this year give a seminar. Also, they could, well, of course, they could donate money. That would be helpful. But also they could offer opportunities for our current students and our graduates. So that would be a way to get involved.
Thanks. Well, thank you.
Any other ideas?
Same ideas. I mean, if there are any kinds of internships or employment opportunities that you hear about that would be relevant for our students, you can email Dr. Smith or myself, and we can make sure that those communications get out to students so that they can apply.
I did have a question come through where, I lost it. There we go. Where do your graduates go after graduation, to work, or what companies they potentially go to work for?
Well, we listed a list of companies, and a lot of those were internships. Do we have a list of the placements for students?
So I guess it depends on which group of students you're talking about. So for our undergrads, we've only got 9 undergraduates who have finished the biomedical engineering degree right now. And with those, they are working at Medtronic, Zymedica. I'm trying to remember what some of the other ones were. Oh, there's the list. I think Monument Health. We've got a couple of those students who are going on to graduate programs. So we've got one who is currently one of our master's students. And we do have an accelerated master's program for biomedical engineering as well. And so we've got several students who are in the middle of working on starting their accelerated master's. So when they graduate with their bachelor's, they'll be here for another year to complete their master's before they go on to industry or academia or whatever their next step is going to be. For our graduates in biomedical engineering, we've had some that work for Stanford Health. We have some that work for Western Dakota Tech. We have some who have started their own independent companies. And then I think that's true for both master's and PhD. And then I'm sure Dr. Smith can talk a little bit more about our nanoscience PhD students.
Yeah, they're all over the country. We have several who are faculty here on campus. We have 2. Both tenured professors, and we have a few around the country, a few in China, and all over the US and the world. Silence.
Thank you. No, that was helpful. Thank you. Okay. Well, just looking. Nope, I appreciate that. That was very helpful information. And you guys do a lot of cool research. We'll have to set up a time to dive deeper into some of the research that you all are doing, because it's very interesting to me. So, and it's good to hear that all this is going on, because I had no idea. While we're waiting for a couple questions, I'm always looking for survey feedback or on the webinar. If there's any ways you want to get involved or topics that you're looking for, I will drop the survey feedback link in the chat. So please feel free to fill that out. And then as always, we're shameless plugs for what's coming up. We do lunch and learn on the 3rd Thursday of every month, and this June the topic is what is CARA. So it's talking about what our new organization, the Center for Alumni Relations and Advancement, what we do over here, what's going on. And then next month we'll be hearing from mechanical engineering, as they will be providing us with an update. We did have a comment come in. Kudos to the department in tech. In 1978, I worked on the SEM using a gold sputter through the metallurgical department. You have come a long way, Dr. Maria Kidner.
Name sounds real familiar. There's a conference room, the Kidner Conference.
Yeah,
Thank you, Dr. Kidner.
yeah. That's cool. We're kind of SEM. Never heard of that. Yeah, and then I'll drop the link for the mechanical one too. So give me a second here. Okay. Yeah. What's a gold sputter?
No,
Anybody?
I mean, it's a coding method, sputtering,
Oh, okay, okay.
typically used for sample preparation for an electron microscope.
Oh, there we go. Yeah. She wrote scanning electron microscope. Oh, cool. Yeah. Good to hear. You learn something new every day. I swear. That's good. Good to hear. Okay. Well, to be mindful of everyone's time, thank you all for coming to today's department update. It was really great. And like I said, if there's any of the research or anything you'd like to hear more from, please fill out the survey and I will work with the departments to get those set up. If we're able to find a time that works. And then everything will be uploaded to our YouTube channel afterwards, once everything uploads. So have a wonderful day and everyone enjoy the rest of the nice sunshine if it's sun is shining where you are at.